So the AI-generated control logic that is validated before the delivery, compliant with engineering standards based on the real hardware context, significantly reduce the likelihood of issues during commissioning.
Welcome to the Trend Detection Podcast, powered by Siemens.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined today by my colleague, Michael Schrapp. And today, we're talking about something completely different to our usual topics of predictive maintenance and related things. And we're actually talking about a really cool product offering from Siemens, the Eigen Engineering Agent. For those who don't know, so it's a generative AI-powered assistant for automation engineering, and it's connected to your portal as well, for those who know. So I'm going to ask Michael to explain that in a little bit more detail, and we're going to go into why it's been created, what type of outcomes is it creating for our customers, and a little look into the future as well. So it's going to be a really cool topic. But I guess before we get into it, Michael, it might be good for the audience to understand a little bit Siemens, and then we'll go from there. So over to you.
So thanks a lot, and thanks for having me here in this podcast. So my name is Michael Schrapp. I'm part of the data and AI organization in Siemens, and I'm responsible for the business development and go-to-market activities for our data and AI products.
Fantastic. Nice to have you. Yeah, nice to have you on the podcast. So, I mean, I guess let's open up the topic. So what is the Eigen Engineering Agent? Why was it created? What was the sort of thought process behind it?
So basically, we came up with the Eigen Engineering Agent, and it was built to reflect a fundamental shift in industrial AI. So moving from assistance to execution. The naming itself signals Eigen, and Eigen in German means your own. So it's a product which is explicitly for you, an agent for you that completes engineering workflows end to end with planning, coding, validating, and iterating autonomously. And the realization was rooted in a real pain point. So automation engineers were spending enormous amounts of time on repetitive manual tasks like generating code, SCL code by hand, scripting HMI screens and visualizations, configuring devices one by one. And a tool that only suggests still leaves the engineer doing the heavy lifting. And what was needed was something that really could plan, act, check its own work, and deliver a finished, validated result, not just. And that's the architectural leap from Copilot originally to an agent, what we just released with the Eigen Engineering Agent.
Fantastic. And I guess, I mean, one thing people might ask first of all is what makes Eigen built specifically for industrial automation engineering versus what some would term using a general purpose Gen AI tool, which we all know who's those providers, but what makes it different to that?
Yes. So I think there are several dimensions where Eigen sets it apart from tools like ChatGPT or the classical IT tools and models. Number one is the domain expertise. So the Eigen Engineering Agent is built specifically for industrial automation tasks with deep knowledge of Siemens tools, workflows, and technologies. Something a general purpose AI fundamentally lacks. The other point is contextual project understanding. So it doesn't just know automation in the abstract sense, it reads and interprets your specific project. So it understands function blocks, it understands user-defined data types, data blocks, knows what an HMI screen is, and the complex relationships. So a generic AI model would require you to manually translate and adapt its output. And it's directly integrated into what we call TIA Portal. The TIA Portal is the Siemens engineering tool for PLCs. And it operates inside the engineering environment, not along with it. So output flow seamlessly integrates into the TIA Portal across HMI, PLC, and drives. And data security and compliance plays a central role. So it is tailored for professional industrial use, ensuring the data is handled securely with full data residency in the respective region. So in Europe, for example, it's compliant with the GDPR. And that's something a general purpose consumer AI tool might not always guarantee. And I mentioned it already a bit. Decades of Siemens industrial knowledge, is built into this tool. So it is built on Siemens real world production experience. So in Siemens, we have more than 100 factories, a lot of experience, a lot of knowledge, enabling it to speak what I always call the language of engineering and follows established convention and industry guidelines. And that's for sure something which is really different and sets it apart from the classical IT tools.
Yeah, and it's interesting you use the term context, because that's come up in a few conversations I've had around predictive maintenance and Senseye. And you're completely correct. That's obviously the differentiation between and generic AI tools. But what does the context mean in practice? And how important is it for the reliability of the tool and the information it outputs?
Yes, so good question. So, I mean, in practice, contextual project understanding means that the agent can interpret the very specific elements of your project. That means it understands function blocks, it understands the data types, the data blocks, it understands tags you have in your project, complex interdependencies and relationships, and what we call hardware topology, right? So the understanding of what kind of hardware you have, the networks, Profinet networks, for example, the I/O signal mappings. And why does that matter? Because without this context, the engineering context, any AI output is very generic and requires manual adaptation, which is very error prone and time consuming. And with it, the agent generates code that already references the right devices, addresses, and interfaces, follows the project's established naming convention, and it fits the existing architecture. So this is the real difference between a result you can use immediately and one you have to rework before it's safe to deploy. And context is what turns AI output into really reliable engineering output. Exactly that what you need in our industrial environment.
And I guess another aspect you mentioned, so you mentioned Tier Portal. So maybe I guess the first question would be to explain Tier Portal a little bit to the audience as well, who may not know much about it. But how does that enable, or what wouldn't be possible without Tier Portal versus including it in Tier Portal? If that makes sense.
Yes. So basically, the Tier Portal is our Siemens engineering tool for the Siemens automation equipment. And what we want to do is with Eigen Engineering Agent, we want to combine that with the Tier Portal, that it works alongside the Tier Portal and is embedded in the existing structures, frameworks our customers are already using. So we have this direct Tier Portal connection, and it enables that we can do real-time assistance with the engineering environment. So there's no copy pasting between tools and therefore no context loss. So it directly interacts with the Tier Portal. There's a seamless output integration. So if the Eigen Engineering Agent generates code, doing configurations and structures are executed directly in the Tier Portal. So not just displaying it as text or visualize it, but it's really executed in the Tier Portal. And this is autonomous execution, meaning the agent can act on the project and not just advise on it. So it's going forth and back between the Tier Portal and our Eigen Engineering Agent. And the user perceives it as one embedded framework. And it's full hardware aware code generation, meaning that once a hardware topology is resolved from an, electrical wiring diagram, for example, the agent generates control logic with full awareness of what hardware is actually doing in the project. And an AI sitting outside this environment, this Tier Portal, would require manual translation of every output, reintroducing exactly the repetitive error-prone work the agent is designed to eliminate.
And again, I think that leads quite nicely onto my next question. You mentioned about sort of error-proof output, and so I'm just wondering, how does it validate the output before an engineer sort of reviews it basically. So what's the, I guess, a bit more technical, in fact, probably, but what's that sort of self-checking loop that happens in the background that it goes through?
I mean, this is handled through our agentic architecture, which operates in basically four structured phases. The very first one is planning. Yeah? So the agent formulates a structured engineering plan before it takes any action. The second aspect is it's using tools, so it executes actions using integrated automation engineering tools. And then the third element is reflection. So as soon as there is a result, this result is evaluated against the engineering standards, safety requirements, and quality criteria we have embedded in our agent. And if the results don't pass it, the agent loops back and self-corrects. Yeah, so it's going back, changing the plan using potentially another tool. It is a dedicated step where outputs are checked against the predefined standards before the engineer ever sees them. And this means the engineer receives results that have already bought AI output only. And the engineer's role becomes more a reviewer and approval role, and he's not an error hunting role where you need to find all the dedicated errors. That's what the agent is all doing for you.
That makes sense. And I guess if we think about sort of tangible examples, so some of the tasks that are seeing the biggest impact today, so I mean, just off the top of my head, PLC coding or HMI visualization. So what are the biggest sort of, use cases around it, and why did you prioritize those first?
Yes. The areas where we and I mean our customers at the end of the day are seeing the biggest impact aligns really directly with the most repetitive, time-consuming pain points in automation engineering. Foremost and really number one is code generation, code development. So there are different languages typically used in automation engineering, but in the past, this was really manually writing either what we call SCL language, or there's also more of a visualization language. But this is very tedious in the past and therefore very error prone. And the agent generates, adapts, and tests the code and resolves, compile the syntax errors in seconds. And we have customers reporting that they achieved the code generation in seconds, and customers who successfully wrote really legacy code, into the new structured code without a lot of additional manual effort. The second topic or the second biggest impact we see in the visualization. I mean, you mentioned already HMI visualization. So that's something where your agent, the Eigen Engineering Agent, helps you to visualize the setup, because this is typically also very repetitive and requires, for example, JavaScript skills. Many engineers not necessarily have. And now the agent automates the screen creation, tag dynamization, and even migrates classical scripts, these scripts. And as I said, without being an expert in JavaScript, for example. And that's really helping to upskill the engineers, to upskill maybe junior engineers or non-experienced people. There are a few other things where we see a lot of impact: drive configuration, for example, or hardware configuration, and what we call ECAD integration. So ECAD is basically electrical wiring diagrams, and what you typically have is a lot of manual re-entry of hardware data from these electrical schematics, which is a bottleneck, and the automatic integration, ECAD integration, eliminates this basically entirely. And I mean, these were prioritized because they represent the highest volume of routine repetitive work, the task where automation delivers the fastest and most measurable return of investment.
No, fantastic. And I guess speaking of return on investment as well, so I think we as Siemens reference really impressive outcomes like 2 to 5 times faster workflows. And then there's a phrase called higher solution quality. So what does that actually mean in reality? And what conditions are needed to achieve those gains?
I mean, the conditions for achieving these gains includes several aspects. Yeah. Number one, using the agent with the TIA portal, having a project with defined structure and context for the agent to read, and applying it to the use cases where repetition is highest. Yeah. So the gains are most pronounced when engineers shift from manual one-by-one workflows to AI-assisted bulk and automated operations. And you mentioned some of the gains already. So what we see is you can be 2 to 5 times faster in execution compared to manual workflows. It also significantly increases the overall quality percent based on an internal study, a field study we did. And it really helps to get up to 50% efficiency gains in these dedicated engineering tasks. And it also really helps to upskill your engineers and to bring them, so junior engineers, to a level where maybe some more senior engineers are. And from a business impact perspective, this is very crucial because we convert engineering efficiency directly into customer benefits. Yeah, so there are shorter development cycles which help the customers to maybe receive machines, lines, and automation updates faster. There's lower rework costs, which reduce the project risk and avoid expensive late stage corrections. And you have faster commissioning readiness, minimizing the delays before the production start. And higher output from existing teams help customers to scale their delivery without being constrained by their engineering talent, which is always limited, right? So we have the talent shortage. And for decision makers, the value is not only that individual engineering tasks become faster, but that project delivery becomes more predictable, scalable, and resilient, yeah, for the customers they serve.
Because we know everything's not perfect in a sort of an engineering environment. So there's sort of undocumented systems, there's inconsistent standards, there's legacy projects, different documentation. So how does it help in these sort of real world, let's say, messy scenarios without increasing risk?
Yes, yes. Yeah, absolutely. I mean, this is where the agent's contextual intelligence and reflection loops are especially valuable. For example, for legacy code. Yeah? So the agent can analyze and document existing legacy logic, adding meaningful comments, rewrite it to modern code, as demonstrated, for example, by our pilot customer TechCap, which successfully interpreted and rewrote the legacy PLC code. Another thing is, as you mentioned already, documented systems. And the project capability provides instant clarity, the overview of all devices and logic in the TIA portal, even though nothing is documented, right? And this really helps the service engineers, for example, and consultants quickly assess the structure, logic flow, and context, even in completely unfamiliar projects you're having. And what, for example, I mentioned already this ECAT, so the electrical CAT integration. So in that, typically the ECAT integration specifically addresses messy real-world files. Yeah? So the agent identifies what would cause native imports to fail. Yeah? Mismatched article numbers, missing network parameters, unresolved device references, for example. And the agent resolves or at least flags those inconsistencies, yeah, issues, before they reach the project, rather than letting them propagate through the project. So it really is able to understand messy, inconsistent input documents, corrects them, and uses it then in the right way. And there are also inconsistent standards, right? So the standards compliant project generation enforces correct framework conventions automatically, reducing the copy paste and adjust patterns that lead to inconsistencies across the machines. So the risk mitigation comes from the reflection phase, yeah, of the agentic architecture. So the agent doesn't just generate and deliver, it really checks its own outputs against the engineering standards before the engineer reviews them.
Fantastic. And I guess wanted to ask a slightly different question as well, because of course this podcast is often, as I mentioned at the start, around predictive maintenance and reliability and maintenance as a whole. I mean, how do you see this fantastic engineering automation agent sort of connecting to those maintenance and reliability outcomes? We all know better asset uptime, fewer logic errors, etc. So how do you see the two sort of work connecting in that way?
Yes. Yeah, I mean, there's a clear link from my perspective. So the AI-generated control logic that is validated before the delivery, compliant with engineering standards based on the real hardware context, significantly reduce the likelihood of issues during commissioning. So in addition, built-in validation mechanisms and these self-correction capabilities help to identify and eliminate logic errors early, preventing many of the problems that would otherwise maybe only emerge during testing or finally live operation, right? So the better you do the engineering and the commissioning phase with a very consistent, high quality, the more positive impact you will have on the maintenance afterwards and the reliability of your machine or line. Yeah? So the reliability is further strengthened through more consistent implementation of changes. So for example, automated compliance checks and bulk update capabilities ensure that modifications adhere to the established convention, reducing the risk of basically inconsistencies across the project, and then also during the runtime. And at the same time, the agent captures and preserves the expert knowledge, making it accessible across teams, also teams working on the maintenance and reliability later on. So what we are trying to do here is to close the gap between engineering, automation engineering, and the operations and service phase of a machine or a line. So covering really the entire, what we call industrial value chain, and therefore significantly helping maintenance, reliability, service activities at the end of the day.
No, fantastic. It's great to see that link as well, because to some they might not be able to see that, but you've explained that really well, Michael. That's great. So as we come towards the end, there is just one final question, and actually it's a question I'm going to ask about engineering and agents, but I think the answer could be applied more broadly than that. But we're focusing on engineering. So if it says if agents are becoming normal, so you could say when, but if agents become normal in engineering, so what changes in sort of skills, government and accountability? And what I mean by that is who rates, who verifies, and how do teams adopt these tools safely? I guess it's still emerging at the moment, but of course, this will become clearer in the future. But what's your sort of take on that?
Yes, very good question. And there will be significant shifts and changes, yeah, in the skills, governance, and accountability. Yeah, but with the Eigen Engineering Agent as one example, yeah, we see that. I mean, this is a true pair programmer, so to speak. Yeah, not a replacement for the engineer, but an amplifier. Yeah, so an experienced digital colleague who works alongside with you. Yeah, so that means it's a kind of a skill shift. Yeah, so engineers move from spending time on manual routine work to higher value adding engineering tasks like creative problem solving, architectural decisions, reviewing AI output. And the agent lowers the barrier basically to entry, enabling engineers without a deep, for example, tier portal expertise to deliver results, but the expert judgment remains essential for review and approval. Yeah? So actually, we are not replacing the people, but we are taking capabilities of the engineer. And there's also governance, which plays a central role here. So the agent operates within a managed service model, so to speak. Yeah, so Siemens manages all AI providers, the security compliance, including cloud hosting. So data privacy and IT are non-negotiable, at least in the industrial environment, with region-specific data residency. So this provides a governance foundation that the teams can rely on. Yeah? So that's, I think, a very central element. And safe adoption is important. So the natural language interface and seamless tier portal integration lower the adaptation barrier significantly. So what we have in our offering, a 1 month free trial and SaaS model, allows teams to start small, validate the gains, and scale the adoption without a large upfront commitment. So basically, the message is agents don't replace engineering judgment. They free them up to operate at a higher level. That's how I see it at the moment.
Fantastic. And so I guess I think the only other question to ask now is, how can people find out more about the Eigen Engineering Agent? Where should they go to find out more information?
Yes, so you can easily go to our website, Siemens.com website. You will find it there. You find all the information. Just type in Eigen Engineering Agent on your preferred search engine. You will get all the information there. And of course, if you are interested in more detail, you can always reach out to the Siemens folks. We are more than happy to support each and everyone getting started with the Eigen Engineering Agent.
Fantastic. So I guess that brings us to a close, but I'd like to thank you, first of all, Michael, for sharing this fantastic product. And I guess it'd be fantastic to catch up in the future as well and see how it's developed further, because I'm sure this is just there's a lot more to come as well.
Absolutely. So thanks again for having me here in the podcast. It was great interaction, great discussion with you, and looking forward to continue this journey.
Fantastic. Yeah, so thank you again, Michael, and I'd like to thank everyone out there for anyone who's listened to the podcast today, and we'll see you on the next episode. Thank you very much.
Please like and subscribe on all major podcast channels. And to find out more about Senseye Predictive Maintenance, go to Siemens.com.